Good afternoon. My name is Oliver Sherman. I'm an SE Director for Juniper's Government, Education, and Medical Practice for North America. As well, I work a lot in the automation and kind of, let's call it, software space. Kind of talking today about a couple things, but primarily I wanted to get started and kind of talk about software because that's the buzzword of that's the latest marketing word we have out there, right? We talk about SDN, we talk about automation, we talk about software as a service, platform as a service, all those kind of pieces. And it's this magical, mythical marketing thing that we're using now to, quite frankly, reinvent things. And while it has some validity, I think there's also some things about it that we can talk about. From an agenda, I will start talking about cloud, just in general. What does that mean? What do data centers look like? How does that play in? How does Juniper play into that? I'll talk about security, some of the things that we're coming out from a security perspective, and then I'll talk specifically, not really in depth, but some of the things that we can do with automation because really we have some unique attributes as a company that we do. Recently in a company meeting, Pradeep Sindhu, our founder, said, the internet is one of the most powerful platforms that we've ever built. If you think about that, that's pretty profound. Everything that we do today is predicated around the internet. All the information we get, all the big data, all the medical transactions, all the government transactions, all those things are possible because of that today. We're connected because of that. If you look at what Juniper does as a company, we've been solving the hard problems of the internet for many years now, since '96. And most of the top carriers, content providers, et cetera, run Juniper in their core. And the interesting thing is, as you look more and more into a lot of the enterprise business, into the government, into education and medical, they all start to look more and more like service providers. Of course, we have the magical, mythical cloud, and as we picture the cloud, this is what it all should look like, or something close to that, rainbows and unicorns. But in reality, this is more like what our cloud looks like today. Mainly because they've evolved over time out of necessity and need. We've plugged things together, we've cobbled things together. And we, as an industry, get to take a step back now and look at what can we do different? How can we build our cloud smarter, if you will? I'm sure there's some priorities you guys are familiar with, and I won't read these to you simply because they're priorities we get from folks like CDG we work with to figure out marketing trends and how do we best fit into that market. But if you look at the components of the cloud, here's kind of the four main things. You've got compute, you've got infrastructure, and you've got storage. The fourth element, and the most important element, is the end user. Because whether you talk about any of those other three components, none of it matters unless the service, the application, or what you're trying to deliver for the end user experience comes across the way you want it to. A couple of components that are relevant to what we do. Connectivity, obviously, is big. Virtualization, whether that's compute or whether that's network. You have service uptime, because quite frankly, we rely on connectivity like we do on electricity and water. And then security. I have all this new big data, all this stuff, and I got to be responsible to make sure that, it doesn't go wandering off. And of course, no conversation is complete without cost control. So, how do I get there? Is it public cloud? Is it private cloud? Is it hybrid cloud? How do I migrate? Is it something I do today, tomorrow? We've gone and we've created an industry or an expectation with our end users that we can't just turn the lights off for 6 months and rewire and rebuild everything and then launch the next thing. And then also from a rip and replace perspective, if you look at a lot of what my competitors do, is they like to create an environment where you have to replace everything in your network. And it's not a bad practice, it's a business problem, quite frankly, because that's a model they have to protect. If you look at the way Juniper started as a company, look back to our service provider heritage, we always had to integrate and innovate and be open, so we play better in those types of environments. Last marketing setup slide, and we'll get to some more fun stuff. But here's kind of the four things that you can kind of summarize this up with. Increased agility. Our friends on the server side have been doing this for a really long time. Down from virtualization to scripting to automated deployments, etc. And been doing it for, 10 years now? And have significantly changed what that industry looks like. I argue that if you look at the network industry in 5 years from now, it looks significantly different. Of course, cost, we'll skip that. It's always about money. We always want to do it better, faster, cheaper. I'll be taking it. And then enhance the experience, again, from the end user perspective. And security, we'll cover that in a little more detail later. So this is interesting as you think of it, because this evolution in technology is nothing new. You look at Wang, the word processor, which was bleeding edge back in the day. I unfortunately still remember that, which means I'm old. They moved to PCs. Nokia used to be the king of mobile phones. I hate to say I carry one now, but they no longer are, right? A lot of folks have dominated the smartphone market. We're kind of watching this trend now. We're watching the gas to electric kind of conversion. And even if you look at the very business models that are out there, they're really changing what we're doing. I think it's one of the most relevant because we think about the way Tesla sells cars. You have governments and dealership unions in Texas and in Georgia arguing that they can't be there because of the model they use to make it more efficient, which is what it's all about, right? So there's some interesting things. IT is the same way. Virtualization we've covered a little bit on the software side. But the network has to move with that. The network's been the piece that's been kind of not quite as flexible in that regard. Three guiding principles from Juniper on the data center, on how do you build a cloud, and we'll do that a little more in a minute. But simple, from a deployment perspective, from a purchasing perspective, from a configuration perspective. I mean, if you think about it, none of this stuff is overly complex, but the more you add to it, the more you build, the more complex it becomes just by its very nature. So create some simplicity into that through the automation, through some of the things that we're capable of doing, really helps out as far as the ease of use and your user experience. And then open. We had a vertical advisory board in Chicago, and it turns out that I had one of the CEOs or CIOs from the University of Hawaii come to me and say, we have these different disparate networks through schools that have been built. They're great, they're awesome, they do exactly what they're made to do. They don't connect together. And that's a challenge, right? That goes to the open standards piece. We've done a lot of stuff in the industry. We've created a vendor lock-in, and quite frankly, that's no longer an option because we have to connect things. We have to be able to move things around. And then, as we look at the software side of it, look at application programmable interfaces. They also have to interact. They also have to be able to talk to each other. But if you look at the overarching promise of SDN, it's that you have an abstraction layer that really makes it easy to deploy anything as you're deploying the application, not the individual. That's smart. We want, self-healing. We've tried that a couple of times to see how that works out. But, smarter from a visibility perspective. How do I get that information? And more importantly, what do I do with that information once I get it? Event correlation. We're starting to develop products that look at things end-to-end from the server side point of view all the way through the network. What kind of reaction or response am I getting? So, but again, if I'm not getting what I want, and I know that already, instead of generating a report, going through a process and having to make a change, why can't I automatically make that change? But with automation comes also a fear of where that change I make as well. And then, of course, security intelligence, meaning how do I do more intelligent things in security? And arguably, I think we've done some interesting things there, which we'll discuss a little more in depth. Our core technology strengths play in all the different disciplines we'll talk about. In this case, this applies to data center. Switching from our switching product line, whether it's some of the campus switches or whether it's the data center switch product line. Core routing, what Juniper started off with, solving the hard problems of the internet, right? How do we make routing as fast as switching? How do you separate control and forwarding? You know, a lot of things that we're trying to figure out today as far as what does this SDN thing mean, we've been doing since the beginning. And then security. From basic security, 5-tuple matches, which we've been doing forever, to NFV services with virtual firewalls, with DDoS secure, and then how do you manage all that? So here's our metafabric architecture. And I won't go too far into the weeds. But there's not a whole lot of magic behind this, except for the things that we've done to integrate and build this, from the chipsets to the way we divide ourselves and things like that. But really what we've done is taken the switching architecture and taken the electric leads out and turned them into fiber and made them longer. So we've eliminated the physical restrictions of a chassis switch. And we've made that into a very large switching platform based on technologies we use in our routing platforms in the service provider space. The interesting thing is, and just like we tend to do as a company, is we started off with a lot of 10 gig ports and tried to sell those to a lot of customers. And it turns out not a lot of customers have a need for 6,144 10 gig ports, or even 768. So we took a step back. We took that architecture and reduced them to the scale and reduced them to the cost to make it more cost effective for shops that didn't need it. The interesting thing is, and this goes back to one of the mantras we talked about earlier, is that we eliminate vendor lock-in. We are open standards, we fit into the data center, but also we have investment protection. We allow you to either have a small 10-member chassis, those components can be redeployed as you grow, past 1 gig, 10 gig, or work in your migration strategy up to 40 to 100 gig without having to replace investment that you've already made, which is quite important because we've been asked to go from a 3-year amortization schedule to 5 to 7 to 10, and the longer we have to make this stuff last, so investment protection becomes particularly important. This is based on a lot of our technologies, so there's our custom silicon, our optics, and of course our operating system. You know, the conversation is never complete without talking about the Junos operating system. If you look at it cross-platform, routing, switching, and security, we run Junos across all those platforms, which, okay, I can argue there's different look and feels to switches than there are routers, but frankly, they do different things. But again, looking at some of the competitive product lines that are out there as I was reviewing this deck, they have different operating systems in the same product family. So you have not only a different reaction, but you have different configurations. So it's an interesting quandary, but these are one of the things that we solve all across our platform. Here you see the individual products, and I'll just touch on it. Virtual chassis fabrics, the magic that pulls all this stuff together. Q-Fabric is that 6,000, 7,000 port monitor I was talking about. We have our EX and MX universal SDN gateways, which support both OpenFlow, support both programmable APIs, and of course you have our security product line. But more importantly, as you start to talk about the software and that abstraction layer, there's a lot of folks that are, don't care about this layer, but care about delivering applications. So how do I build that abstraction? As you start to integrate with VMware, as you start to work with platforms like OpenContrail, which is an overlay SDN solution that we offer. That, by the way, the OpenContrail part is free. There is a paid support model, it's a freebie model that's out there. Those integrations allow you to start getting into service virtualization, delivering on-demand services to your users, either through self-provisioning portals, which ultimately is where we want to go, but more importantly, simply provisioning those for your end users as they require services. And then, of course, getting into OpenStack, CloudStack, some of the big data components and everything else that pours into the software stack that ultimately delivers what we're trying to achieve. Does this make sense? raise your hand. I said, you can't raise your hand. So, our MX series has been one of our most successful platforms. From our universal SDN gateway, meaning we support multiple protocols, we're programmable, either via netconf, your XML API, via OpenFlow, all these things are supported on this platform. And most importantly, it's one of the most flexible platforms because of the trio chipset that's in there. We do service provider managed edge, a lot of things that are now applicable in this environment. EVPN is important as you start to connect data centers. It eliminates the challenge of where did my gateway go? So I don't have to trombone through the initial data center and do some of the things we run into in VM migration. And then some of the mobile stuff that we pull from our service provider friends turn to become very applicable, especially as you look at some of the education markets. If you look at content delivery and multimedia, rather than bring that all over the planet, why can't I cache it through content caches? So, getting intelligence out of the network, meaning the visibility components, we used to do these, or we still do these things on a per device basis. We look at every device, maybe aggregate that to a syslog server or something that becomes an overwhelming mass of information that no human being can actively process. Getting into some of the different ways that we're looking at doing it today, I talked about an agent living in your VM environment, looking at all the data streams, looking at it holistically from an application point of view, really then starts to make a lot more sense. But, how do you integrate that into those products? We're working on a product that does that. We integrate with third parties to do that as well. So again, thinking forward into working. Here's, of course, the promise of where the future of IT is going. I think it's an interesting conversation. And I think that the more we start to automate, the more we start to build these systems, the more intricate they're going to become. While we do reduce OpEx, I think there's going to be some changes that are interesting. So we can chat about that more offline. But again, it's being able to make choices, being able to do the best of breed solutions, being able to come in without being locked in. So let's spend a moment on security. Particularly around firewalls, and we've done really well for some time now as a data center core, where you have high speed, high performance, not a lot of services, layer 3, layer 4, 5 dual match firewalls. They're based on the platform we talked about earlier, which is our MX product line. So this is definitely bigger, better, faster, cheaper kind of environment. But as you move kind of away from the data center, like the edge, you start to want to get a little more application visibility. You want to understand web applications. You want to ensure that you're blocking things you want to block. And of course, as you get to the campus edge, we're starting to talk about some user type things. How do I look at malware? How do I look at the different things that are coming into my network? Arguably, it's taking us some time to get to the far right. So now, from a full security services perspective, obviously the basic firewall, secure router stuff, next generation firewall components are coming in as well, and also the management platform that we have. But what I wanted to highlight today is what we call SecIntel or Secure Intelligence or Spotlight Secure. There's like 6 names for it. Marketing, one day we'll figure out what to do. But this is a case where you start to look at how do I orchestrate intelligence into my security platform. This isn't new, but very much like how Junos was involved. If you look at what's out there in the industry, you get to look at how you would do things differently. And the open platform that we've created allows you not only to get feeds from us, but to use intelligent feeds that are derived from other vendors, that are derived from third parties, or that are derived from the community. In government, education, and medical, particularly education right now, this is resonating really well because you can share data. So if somebody's attacking over here, there's a good chance you're coming from over here, and you can make decisions intelligently in your network based on that. And this feeds in wherever you like, and I'll go over that a little bit more in a minute. But just to highlight that, right, you've got advanced detection tools, of course, but you've got SIM tools that most people own. The challenge with SIM tools is that at the end of the day, maybe an alarm goes off, maybe at the end of the week, I get a report. Awesome. So now I can take that report, I can drive some information off of it, I make a change ticket for my firewall administrator, eventually it gets put in, and however long that time that takes, it may be too long. What if I could take a stream of data and pass that along to a security service and then could pass that on to the firewall? Or perhaps, malware sources. Malware sources change on a daily basis, so how do you get feeds on that? That can be on-premise, that can be, your CERT team. And then, of course, tying into third-party tools and other things that are out in your network today. Not all security intelligence is created equal. A lot of the blacklists, whitelists that are out there today focus on breadth. The challenge with that is, or the selling mentality there is that the longer the list, the better I can sell. But that also creates inaccuracies, stale data, things I'm not reporting. The challenge with that is when you look at perhaps smaller branch type solutions, scale becomes an issue. So how do you ferret that out? How do you create accuracy? And I think we built a backing heuristic system that builds that in. And scale can accept a wide variety of intelligence. And in most cases, most vendors, the answer is no. We also looked at that and changed that. And accuracy, how do you get your accuracy components in? How do you compare that? We obviously have a CERT team, we already have a CERT team, but bringing that all together with the rest of the components. And then prioritization. How do I stop noisy feeds? Meaning, if I have a branch device, I can only hold X amount of data. I want to prioritize what's important to me. So how do you categorize that? Here's kind of the whole framework. I won't read you the slide, I'll give you the basic components that live in there. But here, the slide that will take a cover to build will kind of come out of that. So Spotlight Secure lives in the cloud, gets information from various vendors, whether it's GeoIP information, so being able to block various ranges of IP addresses. And the immediate reaction you always get is when you want to block an IP address that, well, perhaps I can block a large number of end users that I care about. Well, with the way we have things configured, we can deep dive on this at any point in time, but it doesn't necessarily mean that you have to block this individual's IP address. It means that perhaps you're going to do further inspection. Go to your state agency and 89–90% of your traffic comes out of your local state. Things from the outside are okay, but perhaps I want to do further inspection. Perhaps I want to run a signature match on it. Perhaps I want to run it through an extra filter or do a different action. Those are the capabilities that are there. Additional intelligence will come from various feeds. But all this is on-premise, so this is not yet another management platform. This lives inside our security directory platform within a VM called Second Tell that will pass this information. And also accept local application data or third-party data. So if you have systems that are reporting in, if you have a security intelligence team that feeds information back, perhaps to the process right now, this is all a live policy. So you can have this stuff entered real time, having to make configuration changes, limit it, you can build it as what's. This isn't one we'll do problems. We'll do that in a second. Now here's the three kind of use cases that we're looking at now. This is phase one of the rollout of this. If you pay attention in January, some more interesting things will come out, particularly around malware. But this is, the whole piece. When you do the malware piece, you want to destroy the command and control channel. Most systems today have malware on it. The command and control channel is an important piece because we have a lot of botnets, as you'll see. Geo-based traffic. So again, what I can do based on that, and then rapid instant response to the custom feeds. So here's the example of what I was talking about, and really, somebody spent a lot of time animating the little balls of the slide. I think you use this one. But here's kind of the component that's out there. We talked about the 3 use cases earlier. You know, we predominantly sit in a data center or data center edge because of some of the speeds we're able to achieve, some of the things we're able to accomplish. But really, this goes to show that you can bring this solution into anywhere and create classifications to where I'm not dumping the entire databases to every single security device in my network. So I can pick and choose where this fits all the way up to the virtual firewall that can live in your VM environment, or perhaps as a virtual service on your customer prem, on your end user, on your branches, etc. So really some different things that we're doing as we move forward and grow our security. Does that make sense? Let's talk about SDN in particular in automation. If you ask our friends at Gartner, what does SDN mean? They'll say something about money, which is here as well. But it's getting away from per element management to getting to network management. Stepping away from the single CLI, making changes to larger piece. But really, that's not only applicable to networking, it's applicable to the entire software stack. Look at things that, you know, OpenStack and Cloud Stack profess to do. This is where we go. But all the components that are out there are building blocks. We start off with something simple like zero-touch provisioning, and we're able to deploy equipment that moves into add, moves and changes, that then moves into orchestration, that then brings into the greater piece, you know, how do I deliver this application, and all of a sudden you become as elastic as a company like Jinja, who does the model works type product. We didn't start doing software because everybody started doing software in the network. We didn't start doing automation because automation is something we had to get into with our competitors were doing. We launched our XML API, or Application Programmable Interface, in 2001. The reason for that is, and as your network starts to look more and more like service provider networks, we've always had to think that mentality of efficiency and how do we scale? How do we scale beyond the several box solution? And we always fit in that space really well. As your networks look more and more like that, you want to think about that as well. One of the things that's important, and again, this goes back to the One Juno story, is our XML API. The bottom of the slide talks about screen scraping versus utilizing an API. If you screen scrape a device, what you end up doing is you're expecting a response just like you would as a human interacts with a machine. It's called spec scripting. The problem is that sometimes the vendors change the syntax in the way that we return things on the command line. This causes an error, which makes you have to debug your program, which creates a self-leaking ice cream cone, if you will, or self-perpetuating problem of having to continuously debug your program. The return on investment that comes out of maybe it's too loud, that's good. The return on investment that comes from automating your things. We, however, use the XML API, we use netcopy, a couple of different things. But if you look at the layer of which we speak to our devices, if you look at the layer of which we speak to our devices, you're talking the same way we speak to our devices from a CLI perspective. So when I type to the CLI, I utilize the same API you utilize to program it on my device. What that means is something will never ever change. I'm an engineer in the suit. What that means is that likelihood of us changing it is very, very small. The other piece is too, if we look at netconf and protocols where you can speak to the device from a remote perspective, this is is the same way we use our network management platform. So definitely something that that is beneficial if you're automating systems. My favorite quote, this comes from a presentation I did, I don't know, 5 years ago now at OneNet, which is the Oklahoma Backbone Network. But Junos prevents stupid. I mean, it's an interesting quote because back then we were talking a lot about unbox scripting. Taking business logic and applying it to the platform is what we started off with first. We do, in a second, but we're able to take Slack scripting, which is based on XSLT, we don't have to talk about both, they're interesting languages, but basically converting XML to XML to prevent mistakes in your network. So if a network operator, perhaps, they're in the middle of the day, clears all your routing tables and makes your network do the wave in the middle of the day, that's not a good thing. You can prevent that. Or perhaps you have configuration things you want to enforce, like preventing somebody from committing a configuration if there's no interface description. Simple business logic things you can do to prevent your network from going down. 70% of network outages are still caused by human error. Stole this slide from a good friend that actually started a lot of this automation practice. The reason we utilize it because when I ask anybody what they want to automate in your software stack, in your network, wherever it is, the answer is everything. You can break that down though. You can also break it down into what a vendor can deliver. Think of this in the concept of a banana split. If I want to go get a banana split, I go to Baskin Robbins, I get a banana split, but I'm subjected to what they want to give me. Random ice cream, the 42 flavors or whatever they have, type of banana, whatever comes with the banana split, I get that. And that's maybe 80–90% of what I need. That's what network management platforms are. We as vendors give you 80–90% of what you need, and there's lists that we all business prioritize to figure out, what do we put out in the market, what's the most demand, and there's revenue. Now, self-service, in this case, frozen yogurt, Froyo, gives you a little more flexibility. Now I have a little more choice of the sprinkles I use, perhaps, but I'm still limited to brands and things there. But those would be like frameworks, like maybe Puppet or Chef. Who's heard of Puppet and Chef? And you can't, you've heard of it. So just to touch on that briefly, looking at our server brethren, we have a lot of automation tools that are out there that build servers and server-side components. In this case, Puppet and Chef do cataloging services that say you're going to be a Linux server or you're going to be a Linux system, meaning there's these 5 servers that run these different services. With that, you have a limited set of things that you can do to maintain those servers. Well, we've applied that to networking to where you now can do the same, but you can only change a limited subset of things. In this case, IP address, VLAN, that kind of thing. So in this case, you have choices that you can do more than you can perhaps with a network management platform and integrates more into your system. But I still can't do everything that I want to do. So I'm now at 95%. You have the grocery store model now where you have more variety, more things that you can pick at. In this case, it would be something like Ansys Works, which, short explanation, is a framework that does primarily bench automation. Same kind of thing as Puppet, but it's more flexible. Those are open at the bottom end. I can write my own modules for it. Those are written in Python. Which brings me to DIY. The DIY, I can do whatever I want. I can buy the brand ice cream, I can make my own ice cream. I can put bourbon in my ice cream. Whatever makes me happy, right? This is the same thing. We've adopted a modern programming language like Ruby, Python, etc., where you can build your own system. And none of these are mutually exclusive. Because of the way our API functions, you're able to then either utilize these together, utilize them independently, and build the solution that suits your needs. It's kind of what I call the path to SDN, which are really the 3 pillars, if you will, of how do we get to SDN? What are the things that we eliminate initially? The lowest hanging fruit in any environment is zero-touch provisioning. Reason for that, any Anybody who spends time with a service provider, enterprise, anywhere, understands that deployment of equipment is the most expensive that's out there. That's why we talk a lot about NFV, which is I stick a server out there somewhere and I can spin up network virtualization, network services as I need them. However, there's still the provisioning of equipment ultimately is going to be out there. And a lot of vendors have a lot of different solutions. We have some that are either very out of the box, meaning again going to that ice cream model, very Baskin Robbins. I have to have this environment so I can do this. But when we customize it, I can build it all the way out. So a lot of our competitors have black box solutions that you can't really build any customization. And of course, add moves and changes, things we talked about a little bit. Juno Space is the Juniper management platform. Think of it, however, as a platform like your cell phone is a platform. It has different applications that live on that, very much like apps that live on your phone. In this case, for network management, we have Network Director. For security management, we have Security Director. But we also have ServiceNow, which is a Juniper developed application that is what I call OnStar for networking. What it essentially does is if something breaks in your network, I think it's 700 different events, don't quote me, on a piece of networking equipment, it will actually gather the necessary logs, send them to your partner, and then you're able to create or troubleshoot. Back it up. Your partner is able to assist you in troubleshooting and either then pass that on to Juniper service desk or replace equipment for you on the fly, and it really helps save that downtime. The interesting thing is that if you think about failover these days, if I lose an Ethernet port, chances are I'm not going to lose a lot of traffic on failovers. But if I don't know that Ethernet port failed, that's it. So this kind of helps eliminate some of that. We talked about Puppet and Chef, we talked about Python, the Junos SDK, or what's being transitioned to a different platform that allows you to develop applications that actually run on the box itself. If you look at the Puppet example, there's actually an agent that will run within the Junos platform on the switch. So it's a third-party app that lives on our box. Now, that makes people nervous, but for security risks and all those other things, it runs in an outside space, very much like a protected memory space. Exactly like a protected memory space. And orchestration, integration with OpenStack, CloudStack, Junos Contrail, Open Daylight. We're involved in a lot of the SDN efforts that are out there today. I think that, or I would argue that OpenStack and Open Contrail together are one of the most efficient NFV solutions I've seen out there that actually do something that I think is relevant to a lot of the business cases that we have. The other stuff still under an academic perspective. Wanted to touch briefly on ZTP. Mainly it took me a long time to animate that slide. But here's an example of what happens in a basic environment that I do zero-touch provisioning. Those of you that have been doing this for a while in the room will recognize this as Pixie Boot. We've been doing this since the 80s. It's DHCP and TFTP in a basic sense. In our case, we'll boot up and we'll get a couple attributes from the DHCP server that says, what kind of operating system version am I supposed to have? If I need it, I'll upgrade. Where's my bootstrap configuration? And if I'm using our network management platform, I will announce myself from the network management platform, and I can provision then templates or whatever I have. This is extremely basic, but I can also, with that bootstrap configuration, pass a very simple script. I can do things like take a little web server with a curl call that gives me a serial number or IP address. It gives me some distinguishing marker, maybe of my upstream LLDP neighbor, all these look at. I won't go too far down the weeds. But at that point, I can make an intelligent decision, and I can then connect back via the NetCom protocol and push any configuration I like. So I can create dynamic configuration on demand. So there's a lot of flexibility in what we can do. The reason I highlight that more than I used to, because maybe you've heard the story before, is that now as I get on customers and I bring up zero-touch provisioning, I've gotten a couple of scouts. It appears that our competitors have very locked-in solutions. They want to either use a cloud-based solution that is, pay to play, or want to use a very, very restricted, in-house solution. Here I'll highlight the network management component, in particular, ServiceNow. Now, I can't confess, marketing says this will save you 80% of time in troubleshooting. But what I can tell you is that this eliminates a lot of steps in the troubleshooting process. Step one is the entitlement process, meaning pick up the phone, I call support, whether that's your cable provider or whether it's Juniper, and you get somebody on the phone, they want your serial number, they want everything else, and understand your entitled to support. Then I have to get my logging information, I have to get all these logs, and I go into professional or technical log gathering loop. The ServiceNow handles all that for you. The entitlement's handled, information is passed to your partner or Juniper directly, and then notifications to manage, to get logs, to get data. All those steps are eliminated. So while I can't profess 80%, I can profess at least 4 hours while on the phone with main cases to support you. So from an SDN perspective, we talked about control, support, and separation. An orchestration system that lives at the top of all this. I don't know that I can fill all of this in today, meaning that all the technology is still evolving. But as you start to look forward, into things that we're looking at, you've got our management platform, you've got Northstar, which is a LAN optimization. I won't go too far down that rabbit hole. But in Contrail, you've got all the third-party pieces. All these things are trying to come together to build that ecosystem for the abstraction that delivers the software and delivers the applications that you want to deliver to your users. Because going back to the opening, the internet's one of the most powerful platforms we've ever built. This continues to drive on because the services, the things that we can do, not only from a coolness factor, but from society, from medical, all these applications that we have here, this becomes extremely important. So, thank you for your time. I'll certainly take some questions if there are any, and if not, enjoy the rest of the show.
Thank you.
Questions?